All right, in this one we're going to be talking about 4.4 and 4.5 where we're doing some more factoring here. All right, so remember when you're factoring, if the leading coefficient is 1, like we have in this first example, then you can actually take this and write it down just in the parenthesis form to start off with, right? So we can go straight here. And then you're asking yourself a couple of questions. You're saying, what times what is x squared? So that's x and x, right? And then what times what is 12 that adds to be 8? Right, so these kind of are going together. So what multiplies to be 12 that adds to be 8? And remember, if you have a hard time finding, out some of these, it's best to work organized. So just figure out all of the things that multiply to be 12. So that'd be 1 times 12, 2 times 6, and 3 times 4, right? So you just want to write out all of those factors. Well, it looks like the only ones that will add to be 8 would be our 2 and our 6. And they both need to be positive in order to end up with this positive 8 there in the middle. So I'll have plus 2 and plus 6. And then again, you can check this by foiling that together and see if you come back with what we started with, right? But this is our factored answer. Remember, factoring is just changing the form of it so that you have something times something else, right? That's what factors are, something times something else. All right, but on this second example, on factoring trinomials, our leading coefficient is no longer a 1, it's now a 2. And so when it's something other than a 1, we're going to multiply the first term and the last term together, right? So notice how this is in descending order. We've got the x squared term first, then the x term, and then the whole number, right? So first of all, you should check to make sure those are in descending order like this. And then we're going to do something just a little bit different here, right? So now I'm going to take the 2 and the 5, and I need to multiply those together. So I'm thinking to myself, what multiplies to be 10, right? That 2 times 5, that adds to be that middle number, which is 11. Right? So what multiplies to be 10 that adds to be 11? Well, the only things that multiply to be 10 are 2 times 5 and 1 times 10. And if I do 1 times 10, I get 10. And if I do 1 plus 10, I get 11. So that's what I want there. Okay, but I can't go straight to my parenthesis answers like I did in example 1. Right? What I'm going to do is I'm going to rewrite this as a 4-term polynomial. Right? So remember I said, okay, 1 times 10, 2 times 5, those are my ones that I can choose from, but I want 1 and 10. And so I'm going to take this 11x in the middle and I'm going to rewrite it down as a 1x and a 10x. Right? So I'm going to write this as a 4-term polynomial. So my 2x squared stays the same. My 11x is going to change to a plus 1x and plus 10x, right? Because that's what I decided over here. Multiplies to be 10, adds to be 11, right? And then plus 5. Okay, then here, since now it's a 4-term polynomial, I can actually just do the factor by grouping that I did on the last video, right? So in 4.3, we talked about that. So again, I'm going to split this down the middle, right, and see what my greatest common factor is of the first 2 terms and then the last 2 terms. So of the first 2 terms, I can see that x can come out of both of those. So x factors out, leaves me 2x plus 1. Right? And then on my second term, I can see 5 can come out of both of those. So positive 5, leaving me 2x plus 1. So then Now I'm going to factor out my 2x plus 1 from both of them, so that goes in one parenthesis, and in the other parenthesis is my leftovers, which is my x plus 5. Okay. And then I could check this by foiling it together, right? So let's do that over here. I said that before, but let's check it so you can see what I mean. If I FOIL this together, right, I get 2x squared plus 10x plus 1x plus 5. And if I simplify that, all right, I get this polynomial that I started off with, all right? Because remembering, factoring these is just the opposite. It's undoing the multiplying like we did here in our check. So, all right. And then on part 2, this is just another factor question where our leading coefficient is a 1. So again, I can just go straight to writing down my parentheses. And then I'll ask myself, what times what is x squared? That's x and x. What multiplies to be negative 6? That adds to be negative 1. All right, so I'm thinking what multiplies to be negative 6? That adds to be negative 1. All right, well, I got, I could do 6 times 1, and I could do 2 times 3. All right, and on this one, if 3 was negative, all right, and I add those together, then this would work, because 2 times negative 3 is negative 6. 2 plus negative 3 is my negative 1. So I know I'm going to put a positive 2 in one of the parentheses, and the other one is going to be a negative 3 that needs to be there. So x plus 2 times x minus 3 would be the answer on that one. Okay. 4.5, you do some more factoring, right? And so with this, on some of these, you can still use the same method that we were using up above here, but there's kind of some other things that we're going to talk about that you can do on this as well. But so our leading coefficient on this part A is just a 1, so I can go write my parentheses down, and so that I'm thinking what times what is x squared, right? So that's x times x, and what times what is 49 that adds to be 14? Well, that's going to be 7 and 7. And since it's a positive 14, I know that both of these need to be positive, right? And then I could write this down. My answer could be written as x plus 7 all squared. All right, either answer is acceptable. Just make sure that you know that it could be written either way on that. Okay, and then if we do part B, right, again, my leading coefficient's just a 1. So I'm going to go straight to this. All right, so n times n is my n squared. What times what is 64 that adds to be negative 16? Well, that's going to be 8 and 8 is 64, but in order to get negative 16 in the middle, I'd need them both negative, right? Remember, negative 8 times negative 8 gives me a positive 64, but negative 8 plus negative 8 gives me that negative 16 in the middle. Okay, or again, you could have written it down as n minus 8 all squared, right? Quantity squared. All right, now on this kind where the leading coefficient isn't 1, all right, there's actually still kind of a shortcut that you can take on this. So these are called perfect square trinomials because notice that in my first term, I've got 36, that's a perfect square, and in my last term, I have a 25, and that's also a perfect square. So I can rewrite these And that's what I want to do on this to help, you know, see what to do here. All right, so if I'm thinking about that, all right, I can say, okay, well, how could I get to 36a squared? Well, that would be the same thing as 6a times itself. So it's 36a, I'm going to write down as 6a in parentheses all squared, right? If I squared that, I get the 36a squared. And then I'm going to do the same thing with the 25b squared. Well, if I take 5b and I square it, all right, that would give me the 25b squared. And I like having it this way because then I can see what my two terms are that I need to put in my sets of parentheses here. All right, so I've got 6a and 5b, so I'm going to do 6a, 5b, and then 6a and 5b. And then since my middle term is a plus sign, it's a plus 60ab, then I know both of these need to be plus. Okay, and again I could write that as 6a plus 5b, the whole thing squared, quantity squared. Okay. All right, and then kind of similar on that, and maybe another way that some people like to do this, I'll show you another way, instead of writing it down like the 6a squared, 5b squared. Sometimes people just look at it and say, okay, I can tell these are perfect squares, so I'm just going to say, okay, 16, right, what times what gives me 16x squared? Well, that would be 4x and 4x. And what times what gives me y squared? Well, that will be y and y. And how do I get a negative 8 in the middle? Well, I'd have to have both of these as negative. Right? And if I FOILed these out, I mean, look at what I get here. Negative, when I do the inside one, that's going to be negative 4xy. And when I do the outside ones, right, I also get a negative 4xy, which is going to add to be that negative 8xy that I'm looking for there. Right? So that's why both of those need to be negative. So that's my answer. And again, I could write it as 4x minus y all squared. Ooh. Okay. All right. Also on 4.5, talked about difference of squares. All right. And I want to make sure that it's clear you can factor a difference of two squares, but you cannot factor a sum of two squares. All right, so let's do this first one. If I'm factoring this, all right, again, my leading coefficient's 1, so I could just say, okay, what times what is x squared? Well, that's x and x. What multiplies to be negative 16 that adds to be 0? Right? Because I don't have a middle term, so it's really like I'm saying x squared plus 0x minus 16, right? So what multiplies to be negative 16 adds to be 0. Well, 4 and 4 add to be 16, and if one is positive and one is negative, all right, that will multiply to be a negative 16, and if I add those together, that will give me the 0 that I want in the middle. All right, so I can factor this difference of two squares that way. But what if I had x squared plus 16 and it was asking me to factor this? All right, well, when I try and factor this, all right, what times what is x squared? Well, x and x. What times what is 16? And if I put 4 and 4, all right, how do I end up with 0 in the middle? Right? Well, if I make one of them negative and one of them positive to end up with 0, then negative 4 times positive 4 gives me a negative 16, not a positive 16 that this has. So this can't ever factor. So when you have a sum of squares, all right, so something squared plus something squared, right? So it is prime, which means it's not factorable. Okay, so you can't factor it anymore. So x squared plus 16 cannot be factored. There's nothing more we can do with that. Okay, and that's always true when it's something squared plus something squared. All right, let's look at part B, because this one sometimes can be a little bit tricky looking at this. Maybe I'll put it over here. So let's see here. So 2b says 4x squared minus 25. All right, so I'm looking at this and say, okay, I can tell that these are both perfect squares, right? 4 is a perfect square, 25 is a perfect square. But I'm going to rewrite these again as something squared minus something squared, so that it's in that form of the a squared minus b squared. All right, so when I'm thinking of this, what times what gives me 4x squared? Well, that would be 2x times 2x is 4x squared. What times what is 25? That would be 5. Okay, so when you think about, there's, if you have a squared minus b squared, that's always going to factor to be the a plus b times a minus b. So it always factors this way. And so if you know what your a and your b are, then factoring this is pretty simple. So I'm going to call this my a and this my b. And then if I factor this, right, then I'm going to have 2x, right, because that's my a, right, so I'll have 2x plus 5, because that's my b, and then in the other parentheses, a minus b, so that's going to be 2x minus 5. Right? And again, if I FOIL that all together, I'll come back with what I started with here. Okay? So just kind of a way to think through some of those there.